Okay, hello everyone. So today's talk is about data processing units and how they will become more and more important in the future inside the data center, but not just the data center itself. So first thing first, I'm Oliver. I'm the Vates CEO and co-founder. I created Zen Orchestra and XCPNG projects, but today it's not about this. It's all about those DPUs. So if you want to get access to the slides elsewhere on your own browser, you can access them from vates.fr/DPU here if you want to get access to the links in details. So this talk aims to make a kind of intro on the DPUs, to explain what is a DPU and why it exists in the first place. So, and also why do we need them potentially? And the funny thing about it is the first time I heard about the DPUs, it reminds me a lot about the Amiga 500 coprocessors that you have inside the machines. So for example, like a coprocessor to handle the audio and all that kind of stuff. So is it something like this or not? We'll see. But first, before talking about those DPUs, let's talk about the ancestors. So first came the CPU, as you all know, the central processing unit. So CPUs are here from a very, very, very long time. Those CPUs are here to manage almost everything we did since a while. So they can do a lot of different tasks. They are pretty fast. They also have a lot of different instructions, and some says there's too many instructions on modern CPUs. The only problem, I would say, with those CPUs is the limited task concurrency. So it means they are pretty fast to handle serial processing, but when you want to get a lot of parallel work on some kind of data, that's a bit limited. So to solve these problems, then came the GPU, so the graphical processing unit since the 90s, initially used to accelerate your computer graphics, to make a lot of geometrical computation. To do that, it's really, really massively parallel. But the thing is, each, I would say, core somehow handle far less instruction. It's, I would say, a bit dumb per unit. But there are so many of them that you can manage data in a way that's a bit different. And it's not just great for the graphics, but we learned that also it's great for machine learning or big data processing. So GPUs were kind of, I would say, a newer beast in the ecosystem inside our machines. So what about the DPU? So the DPU is all about moving the data around. So basically, so it's pretty recent, it's the last 10 years. Usually it's something that's programmable, so you're using a system on chip. The goal is to provide high performances through, for example, CPU cores. So yeah, might be a kind of CPU, if you like. Also a high performance network interface. The global thing is to also, if you want to do it, to offload things from your main CPU. So you can also put acceleration engines or any kind of stuff like this. So let's go deeper into that. So first, why we need DPUs. So in the last 10 years-ish, we got more and more I/O inside the data center or even outside, either faster networks. 100 gig is, I would say, common in data centers. And we even have a kind of quantum leap on the storage side of things, thanks to the NVMe drive. We got the HDD, then the SSD, then the NVMe drive. And so there's so much data to process very, very fast. And so the amount of data is really huge, but the throughput also is bigger and bigger. And each data might be managed in a specific way. So to do this, the CPU isn't the right answer for those use cases. It couldn't keep up the pace of the amount of data and the bandwidth and throughputs. And the GPUs aren't, I would say, flexible enough to answer that requirements because you can do some kind of things, some kind of mathematical operation, but that's maybe not enough to solve your problems that might be more complex. So that's why we needed something else that's not the CPU nor the GPU itself. That's not the only reason, or one of the big reasons is also on the economical side of things, because when you just remove some work of the existing CPU where it's not really efficient because of its design, which is very in a serial way, well, this offload will also give you less power usage because you will use something that's more made to deal with this kind of data. And it also means that if you offload your main CPU for, I would say, your average compute requirements, it means you have on one machine more power to do more instances, more guests, more VMs, if you like. So for a large cloud provider, it makes sense because you can build more instances by physical machines. So that's also one of the reasons. Also outside the data center, even with I would say a very, let's say, low power processors, even an x86 low power processors, you can get all the hard work offloaded to the DPU. And in the end, that's another brick to the CPU, GPU, and it's another thing that allows you to do very cool things. So it's kind of specialization, at some point to do tasks that didn't really fit with the CPU nor the GPU. So I will do a very quick tour on the capabilities of the DPU. So to give you some example, so it's more, it makes sense. On the storage side of things, what a DPU can do for you, for example, is to expose a virtual local NVMe controller despite being connected on a remote NVMe over Fabric or even your local NVMe drive and cut it into smaller pieces and just expose those virtual NVMe's drive. Obviously, it could do more like, do transparent storage things, for example, erasure coding, compression, encryption, all that kind of things that could be handled directly by the DPU itself. So that you don't have to deal with it. You don't have to think about it. It's, delegating the work, all the storage work and features to the DPU itself. So that's why it could be really handy to do that. The network case is also pretty interesting in the way that I think DPU came from the network world, and because network cards were kind of the first accelerators to start to offload more and more network features from the main CPU, and it's not really something that happened last year. First NICs with offload things are, I would say, 20 years old or something like that. So it's really not new. Basically, now you got, I would say, three categories of NICs. So the first one is just doing basic TCP/IP acceleration, SR-IOV, or even VXLAN offloading. But then we got what we could call the intelligent NICs, where they can do DPDK and other offloading stuff, which is also really efficient to leave the main, I would say, CPU out of it and leave more juice for this main CPU to do all the virtual machine, for example, work and compute work. And then came the smart NICs with far more advanced capabilities. And at some point, the area between smart NIC and DPUs is almost, the same, because in general, a smart NIC could do a lot of things, not just the network. So sometimes you will hear about smart NICs, but it will in general equivalent to a DPU because it's doing far more than just the network thing. So those two terms could be used for the same meaning. If you want to learn more about those examples on how it evolved from the network with basic to very advanced offload things, this link here, well, it's not new, as you can see, and now Mellanox has been acquired, but still it's relevant on the evolution and how the network provided, I think, most of the ideas on offloading things on your main machine, on main CPU to a dedicated card. So that's why network was, I think, one of the, I would say, initial idea of doing DPUs came from it originally. So about the security. So when you have something dedicated to do some task like this, you can also offload all the SSL, TLS computations, Or as I said, for the storage, but also for network, you can imagine you have something that's in the card directly doing the encryption, decryption work for you. So again, it's transparent on your side if you are, in the main operating system or even the virtualized system. Then for you, all of this is handled by the card, and you can even imagine something that's get more deeper in that using more advanced features of the DPU. So this might change a bit the landscape of how we build IT architecture, virtualized or not, by the way, because of how you could count on this small piece of hardware. Regarding the edge, a quick, I would say, thing about it. As you may know, in the edge computing, you don't have the condition nor the house power you might have inside the data center. So it means if you are using small boxes with fanless design, let's say lower CPUs in terms of performances or thermals or the kind of thing, DPUs can provide some interesting things like, delegating some, for example, AI inference. And for example, in retail on a warehouse, when you need to count, products from a camera, webcam or something like that, doing this on the hardware, on the kind of little machine could take a lot of computation efforts on a classical CPU. But if you do that in a specific chip that's can offload this, then you can have very decent level of performances without, getting a very big machine to do it. So it also, as I said, in the storage side of things, high availability and distributed storage that might be really interesting in this context where failure could happen. You're not inside the data center, so power could fail and all that kind of things. So I just drew a kind of a small list, which isn't complete, but I took, I would say, the biggest or the existing products or almost existing products out there using being DPUs, in fact. So as you can see, this is not a small company thing. There's a lot of very big companies working on building those DPUs cards. So you got some Broadcom, NVIDIA, Intel, AMD, etc. And sometimes they are based on an ARM SoC. So basically it's ARM chips with all the memory and everything you need to have a kind of small computer. Some are FPGA, some are ASICs, some with MIPS, CPUs, depends. The last one from a company called Calray with the K200LP is using a kind of specific CPU that's made directly by them. And it's in bold because I invited some of them to be here for the next design session, so we could, talk directly and ask something. We'll talk about this just after that. So I just put a quick picture on what's behind the hood. For example, for the Calray card in question, I just talked about the previous slide. So in this case, you have 80 cores on those PCI Express card, and some cores are used by the control plane, some cores are used by the data plane. But as you can see, the goal of a DPU is to do a lot of different tasks and not just, network or storage or this or that. Ideally, it's flexible enough so you can do whatever load that will be relevant on it, that will be efficient on it to offload your main CPU. So there's a lot of way to do really cool stuff. And usually, by the way, most of those DPUs, regardless, who manufacture it, are, I would say, a large part of them are running on Linux. So that makes sense at some point because it's ubiquitous, but also it means there's a lot of things that could be done inside the DPU itself. So to answer the question I have on, when we started this talk is it just a coprocessor? And I would say the answer is, well, not really. If it's a very basic card, very specialized using an ASIC or an FPGA, at some point, yeah, it might be seen as a coprocessor. But if it's SoC based in general, it's a computer inside your computer, So that's great because there's a huge amount of flexibility and provide you a new way to make, to crunch your data or to go faster in terms of IO. The challenge then, because you add complexities, how to make all those two things communicating together and in an efficient way, so you won't lose time, in CPU cycle just to make context switches to send data to the DPU. So the real challenge is here, and when I say the main OS, it could be also something like a virtualization platform, obviously. So what about the future of DPUs? So there's already people and companies interested in those DPUs, obviously, because they are already started to do that kind of work. Got some example of a company based in UK doing a lot of, I would say, packet processing, and they need that kind of power that you could have inside a DPU or a smart NIC that you couldn't have in another way. So this is already, I would say, relevant for existing use cases, but I think that will be more and more relevant in the future. It could be, and it will be, I think, everywhere if it's easy to use and deploy. That's always the same thing. Technology is meaningful if it's, it answering a need, but also easy to use and deploy. So I think that having something working at some point with a Zen level, with a stack on top of Zen, that would make sense to be relevant and, to continue to have, I would say, really decent use case with something that you couldn't achieve with a classical virtualization. So about virtualization and DPUs, obviously, the main issue that you might have in virtualization is the choice you have to make between performances and flexibility. If you want really, I would say, get the last drop of performances of your bare metal, usually you might use PCI pass-through or static hardware assignments to your virtual machine to get, for example, a dedicated hard drive to your machine or dedicated NIC for your virtual machine. So that's great, it works, but the problem is you will lose the flexibility. That will be hard to live migrate this virtual machine or to even snapshot it if it's using, a hard disk directly. You will lose that kind of flexibility features. And if you use the flexibility features, like, having snapshots or virtual NICs and that kind of things, then it means you have to go through abstractions. And those abstractions were fine in a world where you have 1 gig network or HDDs. But then because of all those devices being far and far faster, then again, you can't really keep up the pace. So you need something that might offload this without losing the flexibility. And I think, in my opinion, that the DPU might be the answer to bring both of the, the performances and the flexibility by delegating what could be delegated to the DPU itself. So regarding the Zen project itself, we could imagine that, to give you some example, that guests could access parts of the DPU or, for example, through virtual PCIe devices, for example, for NVMe drives or for network cards. You could maybe also get the entire Open vSwitch hosted inside the DPU, so you will offload the DOM 0 of all this work. That could be pretty intensive if you have cards that really goes really fast. You got a ton of VLAN, VXLANs, and all that kind of things. That might saturate your DOM 0 CPU. So if you delegate that, that could be a good thing. And obviously, all of that should be handled in an ideal world in a way that's pretty simple to manage. That's something we learn with the Zen Orchestra and XCP Engine projects. If a feature is easy to use, then it will be adopted because it makes sense in terms of performance, but also in terms of integration. So that's why it's really important at some point to get a good integration with that kind of hardware. So that's why we started here to work with Calray, a company that's also based in Grenoble. So we are based in Grenoble, so they are neighbors. That's pretty easy for us to work together. We have a workshop next week to start to make a first proof of concept using PCI pass-through directly on the virtual, NVMe controller and pass it to the VM and make all the tests. That's not the very flexible way, but that will be at least, being able to validate the concept, that the way it works and how it works. And if we have problems with PCI pass-through, I don't know. But I don't think that will be a problem. But obviously, I will let the upstream know if there is anything strange. But the big challenge in the end is really how to integrate that the right way, the way that will be standard, that will be not only for one manufacturer, but for most of the manufacturers. So we had a lot of really interesting design session and discussion about VirtIO support in Zen, and I think that might be something that could be relevant at some point. But we will discuss that in the design session with some Calray people that will be present here. The design session is at 6 p.m. UTC plus 2, so 4 p.m. UTC. So that if you want to try to think together about how to make that integration possible or logical in the future to get something that makes sense and that's universal, that will be really happy to discuss all of that together. So a quick note about VMware, because VMware is also full thrust on the DPU stuff. They created a project called Project Monterey, and they really think that's SmartNICs, and they said SmartNICs, but in this case, that's DPUs. It's technology that will drive an inflection point in hardware and architecture and design. And I think that's not just, the marketing thing. I think that's really true. And they are showing some example here. So they are pushing the concept very, very far. I'm not sure that's the best way to do it. Don't have strong opinion on that right now, but to give you an idea, VMware hypervisor ESXi will be running directly inside the SmartNIC, inside the DPU itself. So for them, it's a way to get another way to control everything outside the classical compute hypervisor. So they want to have two ESXi running in the end, and that's why they started to port ESXi to ARM, because they will be compatible with ARM socks. But I mean, that's a way to do things. That's interesting. They provide some use cases where you could have not even ESXi running inside the host. At some point, you can replace it with bare metal Windows, but it doesn't matter, because in the end, on the bottom of that, you will have some DPUs running with ESXi on it, running on ARM CPU. So that's, I think, will blur a lot of the lines between what component is doing what exactly, and that could provide a lot of opportunities. Obviously, we want to do something maybe simple, or where to contact and to work with the DPU correctly using the right API and so on and so on. But still, that's interesting to see that even big, virtualization provider are working a lot on those topics. So now we'll conclude that, as we've seen, at some point, DPUs are really, I would say, a logical move after the birth of the CPU, then the GPU. There's kind of the third, I would say, pillar of how you could build your infrastructure. And in my opinion, it's also a perfect fit in a virtualization world, because it's able to give a solution regarding the eternal problem of the balance between performance and flexibility. And because it's very programmable, there's a lot of opportunities to work with GPU manufacturers to try to get something that's really cool within the Zen ecosystem. Obviously, there's some work to do, but I think that's not, specific work. That might be something we are already working on with, for example, VirtIO. So that might be another opportunity to prioritize the VirtIO work at some point. But we'll see. Obviously, don't miss the design session. We'll be talking more in depth on how the DPU is working internally and how we could leverage it from the DOM 0, for example, and let's just think about the general design of it. And, if we need to do something else, and obviously if there is some people interested outside the use case I just demonstrated, I will be happy to hear about it. And that's it. So if you have questions, go ahead.
So, Olivier, when you say that ESX runs on the DPU, what exactly does that mean?
When you say what running on the DPU?
VMware ESX.
So basically, the hypervisor will boot on the card directly, so it will be completely independent running inside this card. So that's like if you had Zen running inside the DPU itself.
So it sounds more like you mean the control plane or something, because obviously if whatever's running on the card can't schedule physical like the
it won't. It won't. I mean, it's made to handle the hyperconvergent stuff, the SDN stuff, but also they said host management in a way, maybe you to stop the host and that kind of thing. But it won't, manage the compute hypervisor, what they call it this way. But I'm not sure this design is really relevant, especially for the Zen project, because that would mean to convince manufacturer to get Zen inside the DPU, which seems to be harder than just letting them using Linux, but still at some point it shows that all the possibilities that you can achieve with it. So, but again, I have discussion with some DPU users recently, and they said that the way VMware is doing things seems to be overcomplicated. But I don't have, again, strong opinions myself, because it's something pretty new. I don't use myself yet into production. Okay, so I think we don't have any more questions. So don't forget to, if you have more, want to learn more about it in details, to come to the Zen sessions. So see you later, and thanks.